Okay, in this question we have three compounds. In table 2 we have propanal, prop-2-ene 1-ol and butane, and we're told that they all have an MR of 58. Explain why determining the precise relative molecular masses of propanal, prop-2-ene 1-ol by mass spectrometry would not be able to distinguish between these two compounds. Okay, so precise relative molecular mass is where we have it to 4 decimal places, which can only distinguish if we have an MR of 58, but are made up from different numbers of each element. But both of these molecules, a molecular formula of C3H6O, therefore they will have an identical precise relative molecular mass. Okay, part B. The infrared spectra of these three compounds is shown in figure 4. Use the spectrum to identify the compound. So we need to identify the compound, state the bond that we used with the relative wave numbers. Okay, so there's a couple of bonds on here that we could use. If you look at your data sheet, we have an OH peak here. You've got to be careful with OH peaks because it could be in an alcohol or it could be in a carboxylic acid, and you need to state which one you're using. And then we've got another one here, which is the carbon-carbon double bond. So either of those would actually be okay. The fact of the matter is we've got a carbon-carbon double bond and we've got an alcohol, which means this is the only one with an alcohol, this is the only one with a carbon-carbon double bond. So either argument would be okay there. So compound would be prop-2-ene 1-ol. So if you were going to use OH, you needed to state that it's the alcohol OH, or you could just state the carbon-carbon double bond. And the wave number then, so if you're using the OH, if I kind of divide this into two, if you're using the OH, you've got to quote the data sheet. So there's a peak between 3230 to 3550, and if it's the carbon-carbon double bond you're doing, there's a peak between 1620 to 1680. Again, make sure that you quote those wave numbers from the data sheet. Part C, predict the relative boiling points of these three compounds from highest to lowest. Justify these in terms of intermolecular forces. Okay, so this is a classic one where we would divide this into 3 and we'd discuss each one and then we'd go from there. Let's just have a look at these molecules and let's see if we can identify. So starting with the one with the lowest boiling point, that's going to be this one. So this is going to have the lowest. And again, I'm just doing some working out on here. This is going to have van der Waals force of attraction because all of the bonds are non-polar. The OH here means that this is going to be hydrogen bonded. So this is likely to be the highest. Let's just check that with the other one. So here I've just got a permanent dipole. So this is going to be dipole to dipole. So this is going to be the one in the middle. So what I'm going to do is I'm going to actually put them in order. So I'll start with the lowest. So I'll do butane, propanal, and then prop-2-ene 1-ol. So butane, propanal, and then prop-2-ene 1-ol. Okay, so let's start with the intermolecular forces. So, well, they're all simple molecular, first of all, so that's always a good place to start. So simple molecular, don't forget you must write this out in full, can't use abbreviations. So I would write that right across there, simple molecular. And then the next part, so for butane, This is van der Waals, and again, you mustn't abbreviate this until you've at least written it once, and then you can put VDW in brackets and use that from there on in. So van der Waals forces of attraction. As soon as you mention the word attraction, you must state what it is between. So we've worked out that it's simple molecular, so it's going to be between molecules. Okay. With propanal, so this is permanent dipole. To dipole, forces of attraction. And again, I've mentioned the word attraction, so I have to state what it is between molecules, and again, clue is in the structure and bonding. And then the final one is the alkyl, so this is hydrogen bonds. And again, between molecules. So I've hit every single one of those things there. So now I need to put them in order of the which is the strongest. So this is the strongest. This is the weakest. And I can just do an arrow here, or put that this one is in between. And then, so here, therefore, more, so if I just kind of copy that down there, more energy required, therefore, highest boiling point. Okay, now this is a leveled response question, which means there's three things that you need to kind of hit on all of these. But this table does kind of hit all of them. So the first box here really is stating whether one is higher than the other using the correct amount of terminology. The second rung on the ladder is comparing two again with the answers basically clear and coherent, and then to get 5 or 6 marks, it's putting the relative order of all three compounds with all of the intermolecular forces logically arranged with all the correct terminology. So this table here would hit all of that pretty easily.